Okay, I want to show you how to go about doing the real world blog. This blog is called Molecular Connections, and we have a series of instructions here. The purpose is to really take the molecular naming and formula writing that we have done in class and relate it to things that you would see on a regular basis. So in order to do this, I want you to find an item around your home and look at the ingredient label. I want you to take a picture of that and upload it, and then talk about how what compounds on that label you both know what they are and how to write the formula for. I want you to embed the picture here. I don't want you to attach it. I want you to be able to see it without clicking on something. I want you to find 3 compounds you know and explain how to give the formula, how to find the formula, and then give the correct formula. Now technically you can do this all from one item, or you can use a combination like I did down here. As long as you have 3 compounds, you will have met the requirements, and you can look at the rubric for more details on that. A really cool thing would be if you could find unique compounds or ones that have not already been posted yet. It just gives you an idea to, or a chance to be unique. Now, I'm going to do another blog entry. I do have one down here that shows several different labels. I'm going to do one really quick though to give you an idea of how to do this assignment. So I'm going to title this with my name, and I'm going to come down here and I'm going to say I'm embedding an image from a bottle of shampoo I found this weekend. Now at this point you have to pull up. I've already saved it to my computer. Now it may take a little while to load, but it should come right up. Oops. It's always a good idea to go ahead and say the item description. So this is a shampoo label I found at my dad's. And it pops up. Now if you wanted to, you could make this bigger or smaller. I think we can make it a little smaller just for our purposes. Now, if you read here, I recognize water, zinc carbonate, and honestly, magnesium carbonate hydroxide would be fun to do, magnesium sulfate, and sodium chloride. I'm not stretching myself here. I'm not looking up salts or polyatomic ions that we didn't discuss in class. I'm just trying to connect this to a real world event. So water is a common one. We did this in class, is H2O. Now, this is not how a subscript looks. There's 2 ways you can do this. The first is to highlight the number and to come up here and hit this subscript button. The other is to go ahead and pull up your math editor. You know I like my math editor. And that's what I'm really going to do most of my work in. So zinc carbonate. Zinc is a transition metal. It is an exception and does not use the Roman numerals. To indicate charge. But we know it is a 2+ charge. Carbonate is CO3. Interesting. I'm actually going to three with a 2- charge. So if you leave a space there, it's kind of nice. So to write the formula, I'm going to give myself four fractions. And then I'm going to do the exact same thing again. Now I'm going to set this up like the table in class. So here we have atom or ions, the number, the charge, and the total. Now, here we have zinc, which has a 2+ charge, and we also have carbonate, which has a 2- charge. Move it over so that they are lined up. Now we also know that the total of anything in a compound should be neutral, so that the total positive and total negative charges should be equal to one another. Now these will actually cancel right away. So if I were to have 1 zinc and 1 carbonate, it gives me a total positive of 2+ and a total negative of 2-. That means our formula would be zinc carbonate. Magnesium sulfate. Oops. I wonder. Nope. Oh, hey, you could. You can actually use the same tables if you want. I'm going to copy this for next time. So for magnesium, we know that magnesium is an ion. It's in group 2, so it has a 2+ charge. So magnesium sulfate is a compound that contains a group 2 metal and a polyatomic ion. This is really slow. So we know sulfate is SO4 with a 2- charge. So again, we're going to need 1 and 1. If I have 1 of each, I get a total positive charge of 2+, total negative charge of 2-, which will cancel out in the long run. So that gives me magnesium. I'm not going to write the 1 because it's understood. Sulfate And again, I'm not going to write the 1 because it's understood that this has 1 sulfate. I'm going to add these 2. And if I want to, I can do another one for my sodium chloride. So sodium chloride is a binary ionic compound containing a group 1 and a halogen. Okay. I'm going to go ahead and stop the video. You guys get the idea. Once you have your 3 compounds written out with explanations, you can post it to Blackboard.